All right, so in example 2, it says in a triangle ABC, find angle A to the nearest tenth of a degree. And it gave us that side A is 6, side B is 3, and side C is 4. We're after angle A, and so when we look back at those formulas, we have one that has angle A in it, and it tells us that A squared is equal to B squared plus C squared minus 2BC cosine of angle A, right? So let's just plug in what we know, and let's just algebraically get cosine of A by itself, and then we'll solve for angle A. So 6 squared is equal to 3 squared plus 4 squared minus 2 times 3 times 4 cosine of A. Okay, so just simplified all my squares and my multiplying and everything. And now I'm just algebraically going to get cosine of A by itself. So I'm going to subtract 25. So 11 equals negative 24 cosine of A. And divide by the negative 24. And so when I do this, I get cosine of A is equal to negative 11 over 24. But remember, we're looking for angle A, aren't we? And so what do we do when we're looking for an angle? The inverse. So we're going to do the inverse cosine of the negative 11 over 24. That's something to be cautious of. Remember, anytime we're doing the inverse here, that number that we're plugging in has to be between negative 1 and 1, right? According to our unit circle. Negative 11 over 24 is between them. I'm just reminding you, because if you get an error, that's probably why. You need to just check it. And so what did we get for our angle? Rounded to the nearest tenth. Yeah, that's what I got too. 117.3 degrees. Now, do we need to check for a second triangle? Where is cosine? Well, like in this case, it was a negative 11 over 24. Where's cosine negative? Quadrant 3 and 2 and 3, correct? Can I have a quadrant 3 angle in my triangle? Quadrant 3 angles are between 180 degrees and 270 degrees. Can my triangle have an angle that big? No, because all my angles have to add to be 180, right? So it won't have any quadrant 3 angles. Will it have any quadrant 4 angles? Well, quadrant 4 is between 270 degrees and 360 degrees. So no, it won't have any quadrant 4 angles either. The reason I ask that is because if this had been a positive, cosine had been positive, what quadrants is cosine positive in? 1 and 4, but you said 4 doesn't work. So law of cosines won't give me a second triangle. All right, so we don't have to check when we're using the law of cosines for that second triangle. So there's our solution.